Welcome back to part 3. How many solutions could the equation x cubed minus x squared minus 4x plus 4 equals 0 have? Well, the degree is 3, so it could have 3 solutions. This degree 3 polynomial could have 3 zeros. Let's list the possible rational solutions to this equation. Remember, rational zeros have to be a factor of the constant term divided by a factor of the leading coefficient. So here they have to be a factor of 4 divided by a factor of 1. So the possibilities are positive or negative 1, 2, or 4. So that means that if all 3 solutions are rational numbers, they have to be on this list. That doesn't rule out that they might not be irrational numbers like the square root of 2 or imaginary numbers like I, but if they are rational numbers, the only possibilities are positive or negative 1, 2, or 4. Now let's actually find the actual solutions. There's different ways we can do this. One possibility would be just trial and error. We could pick numbers on this list, plug them in for x, see if we get this to come out equal to 0, and if we can find 3 solutions, 3 numbers that make this work, we'll have all the solutions. Like, for example, if I plug in 1 for x, 1 minus 4 plus 4 does equal 0. So 1 is a solution. The problem with that trial and error method is it might not find all the solutions, because some of them might be irrational or imaginary, or you might have the same number as a solution of multiplicity more than 1. Another thing we could do would be to get a graphing calculator or a graphing software and ask it to draw the graph of y equals x cubed minus x squared minus 4x plus 4. And look at the x-intercepts of that graph, because the x-intercepts of the graph of a polynomial function are the same as the real zeros of that polynomial. Now, the problem with that is that that would only show us real zeros. So if there were any like imaginary zeros, we wouldn't know what those are. And we'd have to be able to tell from the graph exactly where the graph was crossing the x-axis. But that might help. Another possibility with this particular example is this polynomial can be factored by grouping. So it is possible to factor this, just start by factoring by grouping and get it all pulled apart that way. But that doesn't always work. It works here, but there's lots of polynomials that can't be factored that way. So here's how I want to do this. We can start by trial and error, but instead of just plugging in the numbers that we're trying and seeing if we come out with 0, let's do synthetic division. Let's try 1 by setting up synthetic division with 1, negative 4, 4, our coefficients, and we put 1 out in front, and we go through the synthetic division. We get a remainder of 0, which means that, yes, 1 is a 0 of this polynomial. But we get some additional information besides that. We know that this polynomial factors into x minus 1 times x squared minus 4. Now, where did that come from? Well, the x minus 1 is what we were dividing by. The 1 out in front means we were dividing by x minus 1. And the x squared minus 4 is what we got as a quotient. The numbers on the bottom row gave us the quotient, 1x squared plus 0x plus negative 4. And now that we have that, we can take this x squared minus 4 and factor it further. That's a difference of 2 squares. x squared minus 2 squared. So I know I can pull that apart into x plus 2 times x minus 2. And now that I have this all factored, for the whole thing to equal 0, x could equal 1 or -2 or 2. There's one solution for each one of these little factors, one solution that makes each individual factor be 0. So the solutions are 1 and -2 and 2, and those were on the list. Next example, list all possible rational zeros of f of x equals x cubed plus 15x squared plus 47x plus 33. So factors of the constant term are positive or -1, 3, 11, or 33 itself. And then they can only be over 1 because that's the leading coefficient. So that's the list of possibilities. Now, this polynomial function could not have any positive real zeros. Can you see why? You're welcome to pause the video if you want to think about it for a minute. But think about what would happen if you plug in a positive number for x. So a positive number cubed is positive, 15 times a positive number squared is positive, 47 times a positive number is positive, 33 is positive, and if you add a bunch of positive numbers together, there's no way they could add up to 0. So there's no way that you could plug in a positive number for x and have the result come out to be 0. Now, the fundamental theorem of algebra tells us that there must be at least one 0, but it can't be a positive real number. So you might have negative zeros, you might have imaginary or complex zeros, but you can't have any positive zeros. So sometimes by looking at those coefficients, we can get an idea of whether we could have any positive zeros, and we can go a little bit further than that. There's something called Descartes' rule of signs that gives us some information about how many positive and how many negative zeros a polynomial might possibly have. And this is named after the same mathematician and philosopher René Descartes that you might have heard of in connection with Cartesian coordinates or some other things in math or philosophy. And it's kind of harder to say what the rule says than to actually use it once you know it. It's not as bad as it looks. But here's what it says. Suppose you've got a polynomial with all real coefficients and a non-zero constant term. Look at the coefficients of your polynomial and count how many times they change sign, going from positive to negative or negative to positive. That number of sign changes tells you how many positive real zeros you could have. It's either that number, or it's that number minus 2, or it's that number minus 4, but it has to be that number minus some even number. So that tells you how many positive real zeros you might have. If you want to know how many negative real zeros you might have, you can look at the coefficients of f of negative x. That's where you go through and you replace every x in the polynomial with negative x, and you use the fact that negative x to an even power comes out positive, but a negative to an odd power is negative. Then you count the sign changes on the coefficients of that, and that tells you how many negative real zeros you could have. It's either that number, or it's that number minus 2, or it's that number minus some even number. So the example we were just looking at, the polynomial was x to the third minus x squared minus 4x plus 4. So those coefficients were positive, and then negative, and then negative, and then positive. So going from positive to negative counts as a sign change. Negative to negative no sign change there, but negative to positive, that's another sign change. So there were 2 times where the sign changed when we went from one term to the next. And that tells us that this polynomial had either 2 positive real zeros or none. So out of all 3 zeros, either 2 of them are positive real numbers or none of them are. And then if we go through and we replace every x with negative x, so we're looking at negative x to the third minus negative x squared minus 4 times negative x plus 4. A negative to the third power is still negative. A negative squared is positive. A negative is negative. And so this becomes negative x cubed minus x squared, and then minus minus plus 4x plus 4. And now this just has one sign change, one place where you go from negative to positive. So there's one negative real zero. Now, if you remember what the zeros were, they were 1 and 2 and negative 2. So yes, 2 of them were positive and 1 of them was negative. One more example. How many positive real zeros could the polynomial negative 3x to the fourth minus x minus 7 have? Well, notice all the terms have negative coefficients, no sign changes there, so no positive zeros. How many negative real zeros could it have? Well, if we go through and replace every x with negative x, a negative to the fourth power comes out positive. So we get negative 3x to the fourth, and then minus a negative is plus x minus 7, and that has 2 sign changes, minus to plus and then plus back to minus. So that tells us that there are either 2 negative real zeros, or it might be 2 less than that, 2 minus 2, which is 0 of them. Now the degree is 4, and that means there's 4 zeros in all. So out of those 4 zeros that polynomial has, counting multiplicity, none of them are positive real numbers. It might be that 2 of them are negative real numbers, or it might be that none of them are. So what about the others? Well, the others would have to be non-real complex numbers. So it might be that you have 2 negative real zeros and the other 2 involve I, or it might be that all 4 of those zeros are non-real numbers involving I.